right, tonight we're looking at Wednesday night's homework from this week. There are several of these that you should be able to do on your own, like numbers 1 and number 2, you should be able to do on your own. Um, and you should be able to do this one on your own as well. So let's look at the rest of these. Starting with number 3, it says, Karen has a beaded necklace business. She can make 12 necklaces in 2 hours. How long will it take her to make 9 necklaces? So, once again, we're comparing two things. And when in doubt, when you don't know what else to do, put it in a ratio box. But because we're comparing necklaces and hours, we have two different units of measurement going on here. I'm going to make a ratio box. And I'm comparing necklaces to hours, necklaces to hours. And the first column, remember, is our original ratio, comes from the statement, the word problem itself. And it says that she can make 12 necklaces in 2 hours. The second column is for our the question part. And we want to know how long it will take to make 9 necklaces. So that 9 necklaces is going in the necklace box. We don't know how many hours, so we need to solve that. So to solve it, we're going to cross multiply 9 times 2. And then so we've got 9 times 2, and then we have to divide it by 12. And so when you do that, it should give you your answer. Okay. Next we have, how many decameters are there in 4.5 kilometers? Okay, well, a decameter it's 10 meters equals 1. Sorry, that's not right. 10 decameters equal 1 meter, and 1,000 meters equals 1 kilometer. Okay. I'm sorry, that's not right either. One day, Miss Pittman is going to remember her units of measurement. All right, 1 decameter equals 10 meters. So what we need to do is we need to convert either one of these or another. We need to probably convert this to meters. So if I have 4.5 kilometers, that means I actually have 4,500 meters. So I have 4,500 meters, and I want to change it to decameters. So 10 meters equal 1 decameter. So what I'm going to do, I can come over here and draw my ratio box if I want to. And I have decameters to meters, decameters to meters. And this is my original ratio. So 10 meters equals 1 decameter. So if I have 4,500 meters, how many decameters am I going to have? So I'm going to cross multiply 4,500 times 1, which is just 4,500, and divide it by 10. And I'm going to get 450. So there's 450 decameters there. Okay. Next one, we have Naomi has 45 minutes to get ready for school. She spends X minutes getting dressed. Write an expression that represents the number of minutes she still has to get ready. So let's read that all over again. It says Naomi has 45 minutes to get ready for school. She spends X amount of minutes getting dressed. Write an expression that represents the number of minutes she still has left. Okay, so let's just pretend, let's just plug in a number. Let's say it takes her 5 minutes to get dressed. If I were to add 5 plus 45, is that going to give the total amount she has left? It's not, because 45 is our total, which means we can't go any higher than 45. We're actually taking that 45, and we're taking the time it took her to dress out of that to be able to figure out how much it is to get, how much she has left. So our expression is 45 minus x, that x representing how much it took her to get dressed. All right, next question says list 3 values that would make the inequality true. So this side right here, we have 65 less than 15x. So this is our less than sign, so we need something that's going to be smaller than 65. All right, well, 65 has to be smaller than our answer over here, okay, because it says 65 is less than this over here. And when we have a number and a letter touching each other, that means multiplication. So something times 15 has to be bigger than 65. So to figure out the smallest number possible we could use is division. So if I do 15, if I take 65 and divide it by 15, I'm going to get 65 divided by 15. I'm going to get 4.33333. Okay, so 4.33333. So if I round up and I do 5, if I do 15 times 5, I'm going to get 75. And 75 is bigger than 65. So really, if I started at 5, any number greater than 5 when it's multiplied by 15 is going to be bigger than 65. So I could do 10 and I could do 20. But any number bigger than 5 is going to work for that. All right, so this one I said you should be able to do on your own, so I'm going to let you try that one on your own. The next one we have here says Martha made 3 birthday cards and she wants to make more. If she makes 5 cards an hour, how many cards will she have after 6 hours? We're going to try to reread that again. Martha made 3 birthday cards and she wants to make more. If she makes 5 cards an hour, how many cards will she have after 6 hours? So if she makes 5 cards in 1 hour, we'll come back, we do a ratio box here. No, because we're comparing 2 units of measures, cards and hours, cards and hours. If it takes her if she can make 5 cards in 1 hour, then how many cards can she make in 6 hours? And we can solve for x by cross multiplying and dividing. 5 times 6 is 30, and 30 divided by 1 is just 30. So she can make 30 cards. Well, she's already made 3 birthday cards. So 3 plus the 30 means she has 33 cards after 6 hours. And then the last one we have, find the area of the trapezoid. And the area of a trapezoid has this formula. It's base 1 plus base 2 times the height divided by 2. And I have to sing the song because that's how I learned to memorize the formula. We're going to plug these numbers in here. This is base 1 and this is base 2. So I've got 5 plus 9 times the height, 4, divided by 2. And I should be able to plug that into my calculator and get the answer.